chemists have a rather complex way of expressing chemical changes, and there's a system of symbols and formulas and equations that we need to get familiar with in order to communicate in chemistry. We can take an example here and start by writing out a description, a word description of this reaction, identifying the substances that are reacting and the relative numbers and types of particles that are reacting. So we have 3 molecules of the compound ammonia. So this is ammonia here. Note that we indicated the number of particles, what type of particles, they're molecules, and that ammonia is a compound. Keep in mind that you won't be expected to memorize any names of compounds. We'll always give you tools in order to figure those things out. So we've got 3 molecules of the ammonia, the compound ammonia, react with 2 molecules of the element oxygen. So again, we've indicated that it's an element and that there are 2 molecules participating in that reaction. And to produce, right, so to produce would be the arrow. 2 molecules, again, the 2 indicating how many molecules, a type of particles, and nitrogen dioxide is a compound. So 2 molecules of the compound nitrogen dioxide, and then 3 molecules of the compound water. So you see we've covered how many particles of each substance are reacting, what type of compound they are, and what type of particle they are that are reacting, whether they're atoms or molecules. The next thing we'd want to do is do an atom inventory. In an atom inventory, we're going to do a count of all the atoms that are present on each side of the arrow, so on the reactant side and the product side. So if I take a look at the NH3 part, the ammonia, the 2 in front tells me there's 2 of everything present there. So I would have in the NH3 part, let me just get rid of the description for just a minute. All right, so on the reactant side, we have 2 nitrogens. We're going to have 6 hydrogens. Each molecule of ammonia has 3 hydrogens, and we have 2 of those, so it would be 6 hydrogens. And we look at the oxygen, and there are 2 times 2, 4 oxygen. So that would be our atom inventory for the reactant side. And if we go over to the product side, 2 of the nitrogen dioxide would give us 2 nitrogens. It would also give us 4 oxygens. And then the water, 3 water molecules, which would give us a total of 6 hydrogens and 3 atoms of oxygen. Obviously, we'd have to combine these 2 here, which gives us a total of 7 atoms of oxygen. Now, that seems to be a little bit off from the reactant side. So this equation would not be balanced. It violates the law of conservation of mass because we seem to have created oxygen atoms on the right-hand side of the equation. So we'd have to go back through and reevaluate the balancing of this equation, which we'll practice doing later on. The other thing we want to do is to represent this equation in a pictorial form. So I'm going to use blue circles for nitrogen. So I'm going to put in my 2 molecules of nitrogen here, and I'll use the red for hydrogen. So each one of these is going to have 3 hydrogens attached to it. We'll use green for the oxygens. So there's 2, according to this equation, there are 2 oxygen molecules. And then over on the other side, we've got a nitrogen with 2 oxygens on it, actually 2 of those molecules. So we'll do 2 nitrogens. And put two oxygens on each of those. At this point, it doesn't really matter where we place those things, as long as the relative numbers and types of each ones that we draw are correct. And then we would have 3 molecules of water. So we'll start with the 3 oxygens. And then we're going to add on 2 hydrogens to each one of those. So this would be a pictorial representation of that equation. And again, this one doesn't work out too well because somehow we've gained atoms. So we would have to reevaluate this, this equation. So we'll do some practice problems with this in class. It's important to go through each of those steps. So we have the step where we write down the description indicating how many of each substance there are, whether it's a molecule or an atom, and whether it's a compound or an element. And then we do the atom inventory, and finally the pictures.